Far out in the warm dark of the galaxy, past the last star you could ever point to and name, there is a single point of blue-white fire, no wider than a star but blazing with the heat of many suns, wrapped in a slow, luminous veil of its own breath. It does not sit still and quiet the way our own sun seems to. It is shedding itself into the night, layer by glowing layer, pouring out a wind of its own substance so swift and so dense that the gas streams away from it faster than you could cross a country in a single second. Around it, that outflung gas has gathered into a shell, a faint round bubble of light glowing in greens and reds, the way breath fogs and curls in cold air and then drifts loose. This is a Wolf-Rayet star, and it is among the rarest, hottest and most generous things the universe has ever made. You are floating far above it, watching from a distance so safe and so impossible that none of its fierce heat could ever reach you. The way you might watch a bonfire from across a wide, dark field, feeling only the faint warmth of it on your face and none of the flame. There is nothing here for you to do, nothing to reach for, nothing to hold, nothing to carry away. The star burns and sheds its light, and you simply watch it shine. You have come further than light itself travels in many thousands of years to be here, and yet it has cost you nothing at all, and it asks nothing of you in return. You may let your shoulders grow heavy now. You may let the weight of your head settle into whatever is beneath it. The star will go on shining whether you keep your eyes upon it or not, and that is the first kindness of this place. You do not need to remember any of it. You do not need to keep the numbers, or hold the names, or follow the thread from one marvel to the next. Let the facts move through you the way warm light moves through a window. Some of it warms the room and stays a while, most of it passes on through, and the room is gentler for having let it pass. What stays, stays. What slips away was never yours to keep. Tonight you are only here to rest beneath something vast and bright and very far away, the way you might rest beneath a great old tree without ever needing to count its leaves. Let the mind go loose. Let the breath find its own slow rhythm, and let the shining do the rest. The thing you are watching is, first of all, a giant. A Wolf-Rayet star is one of the most massive kinds of star the cosmos knows how to make. Born with the mass of 20, 40, sometimes more than 100 of our own suns, gathered together into a single roaring sphere. Stars that large do not live the long, slow lives that smaller stars enjoy. They burn through their fuel at a furious pace, blazing through in a few million years what a star like ours will take 10,000 million years to spend. So this brilliant thing before you, for all its size and fury, is in truth a brief flame, a candle of enormous size that burns down with astonishing speed, lighting the dark hugely and briefly before it is gone. There is a strange tenderness in that, a great thing made fleeting, shining all the harder because it cannot last. And it is hot beyond any warmth you have ever felt or any fire you have ever seen. The surface of our own sun glows at about 6,000 degrees, hot enough to be blinding, hot enough to warm a whole world from across the dark. But the surface of a Wolf-Rayet star burns far fiercer than that, somewhere from 30,000 degrees to well past 100,000, hotter than nearly any other star that shines. At such heat, the light it pours out is not the soft gold of our morning sun, but a fierce blue-white, the colour of the hottest part of a flame, the colour of a welder's arc, the colour metal would glow if you could heat it past the point where it turns from red to orange to white, and then to a blue so pure it seems to come from the heart of winter. From your safe distance, it is simply a brilliant blue jewel set in the black. Hold the heat of it in your mind for a moment, because the number is hard to picture and worth picturing slowly. 100,000 degrees is not a heat that exists anywhere on Earth, not in any furnace ever built, not in any fire ever lit. It is many times hotter than the surface of the sun, hot enough that the very light it throws off is mostly invisible to you, poured out not as the warm, visible glow you know, but as ultraviolet, the high, unseen light that lies just past the violet edge of the rainbow. Your eyes were never made to gather it. To you, even up close, the star would seem only intensely, impossibly bright. But the truth of its colour lies beyond the small bright window of human sight, in shades the eye can never hold, blazing all the same out there in the dark. Around that fierce sphere streams the thing that makes it what it is, its wind. Every star gives off a little of itself into space. Even our own sun lets slip a thin breeze of particles that drifts out past all the planets. But a Wolf-Rayet star does not breathe out a breeze. It breathes out a gale, a torrent of its own substance flung off its surface at a speed that is difficult to hold in the mind, often well over 1,000 kilometers in a single second, sometimes 2,000, sometimes more. In the time it takes you to draw one slow breath, that wind has crossed a distance many times the width of the earth. It does not gust and fall like a wind on a hillside. It pours steadily outward in every direction at once, a constant fierce exhalation, the star quite literally blowing itself away into the night. And that wind is not thin, the way you might imagine a wind in empty space to be. It is dense, heavy with the star's own material, thick enough that it hides the true surface of the star entirely. When astronomers look at a Wolf-Rayet star, they do not see its solid face at all. They see only the glowing wind itself, the outflowing gas lit from within, an immense luminous fog wrapped around a heart no eye will ever glimpse. The star you are watching has drawn a veil of its own breath about itself and shines out through that veil, hiding its surface inside its own light, the way a lantern glows softly inside a paper shade and you never quite see the flame. To feel how fierce this wind truly is, set it beside the gentle breath of our own sun. The sun too gives off a wind, a faint stream of particles that drifts out past the planets and brushes softly against the earth, so thin you would never feel it. But the breath of one of these fierce giants is many millions of times stronger, carrying away in a single year what the sun would take an age to shed. It is the difference between a candle's wisp of smoke and a great chimney pouring forth, between a sigh and a sustained roar, the same gentle act of a star breathing out, magnified almost beyond the reach of thought, and yet set far enough away. Even that roar arrives at your watching eye as nothing more than a still and silent light. The veil of wind around such a star reaches far out into space, glowing more and more faintly as it spreads. Close to the star, the gas is bright and dense, packed thick with outflowing material. Farther out, it thins and dims, fading gradually into the dark until it can no longer be told from the empty space beyond. So the star has no sharp edge at all, no clean boundary where it ends and space begins, only a soft outward fading, a glow that gently gives way to dark. It is less like a stone with a hard surface, and more like a candle flame in fog, brightest at the centre and dissolving softly outward into the night. The gas the star sheds does not simply blow away and vanish. For a long while it lingers, glowing, in a great region around the star. Drawn outward by the relentless wind, the shed material fills the space near the star with a faint luminous haze, lit from within by the fierce light at the centre. Astronomers can map this glowing region, reading from its shape and its brightness, how strong the wind has been and how long it has blown. It is as though the star keeps a soft, luminous record of its own breathing all around it, a glowing memory of every year's worth of wind, spread gently across the night for any watcher who cares to look. Because of that fierce, ceaseless wind, the star is losing weight at a rate that has no equal among ordinary stars. It sheds its own substance into space so fast that, in a single year, it can fling away as much matter as our entire Earth holds, and then do it again the next year, and the next. Picture that quietly from your safe remove. A whole world's worth of material, every continent and ocean and mountain range of it, lifted off this star and scattered into the dark, year upon year, for as long as this brief fierce chapter of its life shall last. It is the most prodigal kind of star there is, giving itself away by the planetful, emptying itself into the night with a generosity that asks for nothing back. What that wind is stripping away, layer by layer, is the star's own outer skin, and beneath that skin lies a secret the star keeps hidden for most of its life. Like our own sun, a massive star is wrapped in an outer mantle of hydrogen, the lightest and most common element there is, the same stuff that fills nearly every star in the sky. For most of its life, that hydrogen blanket stays in place. But a Wolf-Rayet star with its furious wind has torn that blanket away. The hydrogen is gone, blown off into space, and what lies exposed now is the deeper, older material that was forged in the star's own heart, the heavier elements cooked up in the long fire of its life. The star has, in a sense, peeled back its own surface to show you what it is made of underneath. What lies beneath that lost blanket of hydrogen is helium, the second element, the one first found not on Earth at all but in the light of the sun. Beneath the helium lie heavier things still. Carbon, the element that makes the lead of a pencil and the diamond on a ring, and the very framework of every living body. Nitrogen, which fills most of the air you're breathing in this very moment. Oxygen, the rest of that breath. The thing that lets a candle burn and a body live. All of these, forged deep inside the star across the long furnace of its life, lie laid bare now where the hydrogen used to be. The inner workings of a star turned outward, glowing openly in the dark for anyone patient enough to read the light. These stars are rare, far rarer than you might guess from how brilliantly they shine. Out of all the hundreds of billions of stars that fill our galaxy, only a few hundred Wolf-Rayet stars are known, a small and precious scattering, like a handful of bright sparks strewn across an enormous unlit hall. You're not looking at something common tonight. You're looking at one of the most unusual kinds of star there is, a thing so uncommon that all of human searching has turned up only a few hundred of them in the entire spiral of the Milky Way. Far below you it burns, indifferent to how rare it is, content simply to shine in the dark while you grow heavier and warmer and further from the cares of the day. That rarity is not because the universe struggles to make them, but because they do not last. A star spends only a brief final chapter of its long life as a Wolf-Rayet star, a few 100,000 years perhaps, at the very end, after millions of years of more ordinary blazing. It is the last bright phase before the end, the closing movement of the most massive stars, and it passes in what amounts, by the measure of the cosmos, to the blink of an eye. So at any given moment, only a few stars in all the galaxy are passing through this stage at once. They are rare not because they are hard to forge, but because their fierce, beautiful chapter is so wonderfully short, a brilliant final breath drawn by the very largest stars and then released. The light these stars give off carries a signature unlike almost any other in the sky, and it was that signature that first gave them away. When the light of an ordinary star is spread out into its rainbow of colours, it shows a smooth band crossed by thin dark lines, gaps where the star's outer gases have absorbed certain colours and swallowed them. But when the light of a Wolf-Rayet star is spread the same way, something startling appears instead. Not dark gaps, but bright bands, vivid stripes of colour glowing far brighter than the light around them. Those bright bands are the fingerprints of the glowing wind, the signature of gas pouring outward and shining of its own accord. To the eye that knows how to read it, a Wolf-Rayet star announces itself in its own light, unmistakable, unlike nearly anything else that shines. It was those very bands that revealed these stars to the world long ago on a quiet evening in Paris. In the year 1867, two astronomers named Charles Wolf and Wolf-Rayet, working together at the observatory there, turned their instrument toward three faint stars in the constellation of the Swan, high in the northern sky. When they spread the light of those stars into its colours, they found those strange bright bands, glowing stripes where every other star showed only dark ones. They did not yet know what they were seeing. They only knew it was something new, something the catalogue of the heavens had not held before. And so a wholly new kind of star entered human knowledge that night, carried in on 3 faint points of light and a ribbon of unexpected colour. The 2 men gave their names to what they found, as discoverers often do, and so these stars have been called Wolf-Rayet stars ever since, a small lasting echo of one evening's careful looking. There is something quietly lovely in that a thing so vast and so distant, forged in fire long before there were any people at all, should carry down the centuries the names of 2 patient observers who simply noticed it was there. The stars themselves know nothing of it, of course. They burn on exactly as they always have, indifferent to the small human names now fastened to them, while those names are spoken softly in classrooms and observatories across a world the stars will never see. The very element that fills these stars was itself a fresh discovery in those same years, found first not in any rock or flame on Earth but in the light of the sun. Just before Wolf and Rayet turned their instrument to the sky, others studying the sun's light during an eclipse had noticed a bright line of colour that matched no element then known on Earth. They guessed it belonged to a new element and named it for the sun itself, helium, from the old Greek word for the sun. Only decades later was that same element finally found here on Earth, and so the gas that glows so brightly in a Wolf-Rayet star was, in those years, a thing known only from starlight, a substance the heavens had revealed before the Earth had ever yielded it up. Not all of these stars are alike beneath their glowing veils, and astronomers have learned to read the differences in their light. Some show in their spectra the bright signature of nitrogen, glowing strongly among the helium. These are one great family of Wolf-Rayet stars. Others show instead the signature of carbon and oxygen. The heavier ash of a star burned further along, these are another family. It is as though each star wears in its light a record of exactly how deep its fierce wind has cut, how many layers it has peeled away, how far along its brief final road it has travelled. The nitrogen stars have laid bare one depth, the carbon stars a deeper one still. The light tells you, if you know how to listen, just how far each has come. The ones that glow with the bright signature of nitrogen are showing you a particular layer of the star's hidden interior, the place where, deep in its earlier life, the star fused hydrogen into helium by a path that leaves nitrogen behind as a kind of trace. To see that nitrogen shining at the surface means the wind has stripped the star down to the very region where that ancient burning took place. You're looking, in a sense, at the exposed remains of the star's own engine, the inner chamber where it spent the long middle of its life turning one element patiently into another, now uncovered and glowing openly in the cold of space. The ones that glow instead with carbon and oxygen have been stripped further still, down to a deeper, hotter shell where helium itself has been fused into those heavier elements. These stars have shed not only their hydrogen, but most of their helium too, bearing a layer closer to the very core. They are, in a sense, further along the same road, older in their dying, having flung away more of themselves into the dark. And in the rarest of them, the wind has cut deeper than almost anywhere else, down to where oxygen shines brightest of all, the deepest layer any living star can show. Each is a different depth of the same slow unveiling, the star turning itself gradually inside out, layer by glowing layer. These 3 families form a kind of ladder, each rung bearing a deeper layer than the last. The nitrogen stars show the shallowest depth, where hydrogen was once gently fused. The carbon stars show a deeper shell, where helium has been burned to heavier ash, and the rare oxygen stars show the deepest layer of all, closest to the searing core. To move down the ladder is to follow a star further along its dying, deeper into its own heart, the wind cutting steadily inward, exposing layer after layer of the long fusion that filled the star's life. It is a tidy order written across the chaos of a dying giant, a quiet sequence the patient watchers have learned to read in the light. Within each of those families, astronomers sought the stars more finely still, by exactly which lines glow brightest and how. A whole gentle grammar has grown up around these stars, letters and numbers that mark how hot each one burns, how deeply its wind has cut, which elements shine most strongly in its light. Behind that quiet notation lies a roaring giant flinging away its substance, and yet on the page it becomes only a calm and orderly label, a small tidy entry in a long careful list. There is a peace in that ordering, the wild fierce cosmos gently catalogued, each blazing star given its small precise place in the human record of the sky. The engine that drives all of this lies deep at the star's core, where helium is being fused into carbon and oxygen in a furnace of staggering heat. A Wolf-Rayet star has for the most part already burned through the hydrogen that fuels stars like our Sun. Now it burns the helium beneath, fusing it into heavier elements in a fire fiercer and faster still. It is a star living off its deeper reserves, having spent the easy fuel and turned to the harder, the way a fire burning low turns from kindling to the dense heart of the log. That deep helium fire is what powers the fierce light and the furious wind, the last great burning of a star near the end of all its fuel. What truly marks one of these stars to the eye that reads its light is what is missing from it, the near absence of hydrogen. Nearly every other star in the sky shows hydrogen plainly in its light, for hydrogen is the commonest stuff of the cosmos and wraps almost every star in a blanket. But a Wolf-Rayet star, having blown that blanket away, shows little or none, its light strangely empty of the most ordinary element there is. To find a star whose light lacks the usual signature of hydrogen is to know at once that something has stripped it bare, peeled away its outer self to reveal the deeper stuff beneath. The absence is itself the clue, a missing colour that tells the whole story. Among the carbon stars, something especially beautiful can happen out in the streaming wind. They make dust. It seems impossible at first. How could anything so cool and dark as soot form in the blistering torrent around a star hot enough to glow blue-white? And yet it does. Far enough out where the racing wind has spread and cooled, the carbon flung off the star begins to gather into tiny grains of dark soot, the same kind of fine carbon dust that rises from a candle's flame. A star fierce enough to burn at 100,000 degrees becomes, at its windy edges, a maker of the softest, darkest dust, strewing it outward into the galaxy, fine as smoke, where one day it may help to build new things. That dust does not always drift away in a featureless cloud. Around certain of these stars it gathers into one of the loveliest shapes in all the heavens, a slow, glowing spiral, a pinwheel of soot turning gently in the dark. It happens when a Wolf-Rayet star is not alone, but circles a companion star in a long, patient dance. The fierce winds of the two stars meet and collide in the space between them, and in that crush of colliding winds the carbon is squeezed together and cools into dust. And because the two stars are forever circling, the place where their winds meet sweeps around and around, laying down the dust in a great curving arm that winds outward, turn after turn, a perfect spiral coiling into the night. The most famous of these spinning shapes turns around a star called by the plain catalogue name of WR104, far across the galaxy, many thousands of light years from where you rest. There, a Wolf-Rayet star and its companions circle one another once in about 240 days, a little under a year, and as they circle they spin out a vast pinwheel of glowing dust, coil upon coil, wider across than the whole orbit of the most distant planets in our own sky. Astronomers have watched it turn, frame by patient frame, and seen the spiral slowly rotate, exactly as two circling stars would draw it. It is one of the most graceful things the cosmos makes, a great soft whirl of soot and light, turning out there in the silence with the unhurried grace of cream stirred once into coffee and left to swirl. Picture that pinwheel for a moment, drifting at the edge of sleep. It is not a wheel of fire or fury, despite the fierce stars at its heart. It is a slow, soft spiral of fine dust, glowing where the starlight catches it, curving outward into the dark in one long, graceful arm that wraps around and around upon itself. Each full coil of the spiral is laid down over one full circling of the two stars, so that the shape is a kind of clock, a record of time written in dust, every turn of the spiral a year, every coil a circuit completed. It turns so slowly that you would never see it move with your own eyes. Only across years of watching does the great pinwheel reveal its patient rotation, winding silently outward, asking nothing of anyone who happens to be looking. Other stars of this kind sculpt their surroundings into different shapes, just as lovely. Where the fierce breath of such a star slams into the slower gas that the same star shed in an earlier, gentler phase of its life, the fast wind sweeps up the slow gas before it, the way a broom gathers a drift of fallen leaves into a ridge. Over time, that swept up gas piles into a great glowing shell, a bubble blown in the gas of space, lit from within by the fierce light of the star at its centre. These are the Wolf-Rayet bubbles, and they are among the most delicate and beautiful structures in the whole night sky. Vast luminous spheres, blown by nothing but the breath of a single star. One of the loveliest of all these shells hangs in the constellation of the Swan, near where the very first Wolf-Rayet stars were found, and it is called the Crescent Nebula. It is a great rounded shell of glowing gas, perhaps 25 light-years across, blown into the dark by the fierce wind of the brilliant star at its heart. Through a telescope it shows us a soft curving arc of light, threaded through with delicate filaments and tinted in the reds and greens of glowing gas, like a luminous soap bubble caught in a shaft of coloured light. At its centre burns the Wolf-Rayet star that made it, breathing out the very wind that piled this shell together, an artist and its artwork, the star and the great soft bubble of its own making hanging together in the dark. The colours that glow in such a shell are not chosen for beauty, though beautiful they are. Each one is a kind of signal telling which gas is glowing and how. The deep reds come most often from hydrogen, the commonest gas there is, glowing in a particular shade when the fierce starlight stirs it. The greens and teals come from oxygen, glowing in its own distinct hue. So the soft watercolour washes of a Wolf-Rayet bubble are in truth a map, a portrait painted by the gases themselves, each element signing its presence in its own colour. The whole delicate shell a kind of luminous chemistry, written across light-years of space and readable from half a galaxy away. Some of these stars do not gather their lost material into a single neat bubble, but scatter it into wider, wilder shapes, great looping arcs and streamers and knots of glowing gas, flung out unevenly across the dark. The wind of such a star does not blow perfectly the same in all directions, nor does the gas around it lie perfectly smooth, and so the shells they blow can be ragged and strange, full of curling tendrils and bright clumps and long faint filaments reaching out into the black. Each is unique, shaped by the particular history of its star, no two alike, every one a different sculpture worked in glowing gas by the patient pressure of starlight and wind. These stars are among the most luminous things in all the sky, not merely hot, but staggeringly bright. A single Wolf-Rayet star can pour out hundreds of thousands of times as much light as our own sun, and a few of the brightest shine with the light of more than 1,000,000 suns. If one of them were set where our sun is, the earth would be scorched in an instant, but set safely far away, across the great gulfs of the galaxy, that same fierce brilliance becomes only a lovely point of light, harmless and beautiful, its torrent of energy spreading out across the dark until by the time it reaches any distant eye, it is gentle enough to rest beneath. Distance is a great softener of even the fiercest things. Most of that enormous brightness, though, pours out in light your eyes can never see. Because these stars are so fearfully hot, the bulk of their radiance streams out as ultraviolet, the high, unseen light beyond the violet end of the rainbow, rather than as the visible glow you know. So a Wolf-Rayet star is even brighter than it looks. Much of its true output is simply invisible to the human eye, poured silently into the dark in colours no person has ever seen. What you would perceive, even gazing straight at one, is only a fraction of the light it is actually giving, the visible tip of a far greater unseen brilliance, blazing on in shades forever beyond your sight. The nearest of these rare stars to us shines, remarkably, with a brightness you could see with your own unaided eyes, low in the skies of the southern half of the world. It lies in the constellation of the Sails, part of a bright star the old sky watchers called by the name Gamma Velorum, and it is the closest Wolf-Rayet star to Earth, though even so its light takes well over 1,000 years to reach us. Some who love the southern sky have given it a fond nickname, calling it the jewel of the southern heavens for the richness of its light. To stand under a dark southern sky and find that point of light is to look, with nothing but your own eyes, upon one of the rarest kinds of star there is, its ancient light arriving softly after a journey longer than all of recorded history. That nearest one is not a single star at all, but a pair, a Wolf-Rayet star bound together with a massive blue companion, the two of them circling each other in the dark. Many of these stars, it turns out, live in such pairs, locked in long orbital dances with another massive star. And those pairings are not merely a curiosity, they shape the very lives of the stars. A close companion can help strip away a star's outer layers, tugging at them with its gravity, hastening the unveiling that the fierce wind begins. So some Wolf-Rayet stars may owe their bared, glowing interiors partly to a faithful stellar companion, a partner that helped, across the long ages, to peel back the blanket and reveal what lay beneath. When two such stars circle close together, each breathing out its own fierce wind, those winds meet in the space between them and crash together in a great shock of colliding gas. Where they collide, the gas is squeezed and heated until it blazes in light of its own, often in the high, unseen energies of X-rays. So a pair of these stars glows not only with the light of the two stars themselves, but with the light of their winds colliding in the gulf between them, a bright seam of shocked gas hanging in the space where two stellar gales meet and break against each other, shining on in colours no eye can catch. That bright seam of shocked gas brightens and fades as the two stars circle, swelling when they swing close and easing when they drift apart. As the pair draws near, their winds meet with greater force, the seam flares brighter in its unseen light. As they part, the collision gentles, and the glow softens. So the X-ray light of such a system rises and falls in a slow, faithful rhythm that follows the orbit itself, a quiet beating pulse, years long, written in light no eye can see, measured patiently by the instruments that watch. From the rise and fall of that glow, astronomers can read the shape and pace of an orbit unfolding far across the dark. The very shape of a single bright line in a Wolf-Rayet star's light carries the whole story of its expanding wind. When gas streams outward toward you, its light shifts toward the blue. The gas on the near side, rushing straight at you, casts a faint shadow on the blue edge of the line, while the rest, glowing as it expands in every direction, spreads the line broad and bright. From that one lopsided shape, bright and wide with a dim notch on its blue edge, astronomers can read at a glance that they are looking at an expanding shell of gas and how fast it is racing outward. A single line of colour read closely becomes a portrait of a whole streaming wind. Some of these paired stars pass directly before one another as they circle, dimming and brightening in a slow, faithful rhythm as one eclipses the other. From far across the galaxy, the combined light of such a pair rises and falls on a steady beat, marking each circuit of the two stars about their common centre. By timing those gentle dimmings, astronomers can weigh the stars, measure their paths, and learn their sizes, reading the very masses of giants from nothing but the rhythm of their fading light. There is a quiet wonder in it, that two points of light, blurred into one across the dark, can be teased apart and weighed by the patient watching of their slow eclipses. The wind of one of these stars is so fierce that it carries away more momentum than the star's own light alone could give it. The light pouring off the star pushes the wind outward, but the gas is so thick that each ray of light is caught and flung again and again on its way out, lending its push over and over, like a single gust striking sail after sail down a long row of ships. By this patient relay, the star's light drives its wind to speeds far greater than a single push could ever manage. It is a quiet marvel of efficiency, the star's own radiance lending its force again and again to hurl its substance into the dark. One such pair draws a shape of extraordinary delicacy as it circles. The two stars travel not in a perfect circle, but in a long, stretched oval, swinging far apart and then close together again across the years. As they swing close, their colliding winds make dust. As they swing apart, the dust drifts free, and because the orbit is so stretched, the dust is laid down not in an even spiral, but in graceful, far-flung arcs that bloom outward only at certain seasons of the long orbit. Astronomers have watched one such system, across years of patient looking, puff out a fresh shell of glowing dust each time the two stars swing near, a slow heartbeat of light, one soft pulse for each long circuit of the pair. Think of that rhythm, drifting here at the edge of sleep, a great slow pulse, years long, beating out there in the dark. Each time the two circling stars draw near one another, their winds crush together, and a new ring of dust is born, expanding gently outward into the night. Then the stars draw apart and the making pauses, until the long orbit brings them close once more, and another soft ring blooms. Ring after faint ring drifts outward across the years, nested one inside the next like the rings within a tree, each marking one full turning of the two stars about each other, a clock of dust and light, keeping a slow and faithful time across the dark. One such system, known by the catalogue name WR140, drew its rings so faithfully that when a great new telescope turned toward it not long ago, it found a sight of astonishing order, more than 17 shells of dust, nested one within another, spreading outward into the dark like the layers of an onion drawn impossibly wide. The two stars at its heart circle once in about 8 years, swinging close and then far apart, and at each close passage their colliding winds forge a fresh shell of dust that drifts slowly outward to join the others. 17 shells means more than 100 years of faithful making, each ring a passage completed, the whole vast structure a record of the two stars circling patiently across more than a century, written in dust and unfolding gently in the dark. That great new telescope, built to gather the warm unseen light beyond the red, saw what no eye on earth ever could, the faint warm glow of dust shells so cool and so far that only such an instrument could find them. Where earlier watchers had glimpsed only a single faint plume, this new eye found shell after shell after shell nested neatly together, each one expanding outward at a steady, measured pace. To see them all at once was to see more than a century of the system's slow breathing held in a single image, every ring a soft pulse from the past, all of them spreading patiently outward into the night together. The dust these systems make is not idle. It drifts out to enrich the dark between the stars with the very substances from which worlds and life are built. The grains forged in those colliding winds are rich in carbon, the same element at the heart of every living thing, and laced with the kinds of complex molecules that may one day find their way into new worlds. So each soft shell of dust drifting outward into the galaxy is a quiet gift carried into the future, scattering the raw material of planets and perhaps of life across the patient dark. These fierce stars, in their dying, sow the seeds of things not yet born. There are two ways these circling stars lay down their dust, and each makes a different shape. When the two stars travel in a nearly round path close together always, their winds collide ceaselessly, and the dust pours out without pause, winding into the smooth, continuous spiral of a pinwheel. But when the two stars travel in a long stretched oval, swinging close only now and then, the dust is made only at those close passages, laid down in separate nested rings rather than a single spiral, So the very shape of the dust, a smooth coil or a set of nested shells, quietly reveals the shape of the orbit that made it, the path of two stars written in the form of their leavings. Far across the southern sky, in a small companion galaxy to our own, there blazes a single star that may be the most massive ever found. A Wolf-Rayet star so enormous it was born with more than 200 times the mass of the Sun, pouring out the light of several million suns at once. It sits at the heart of a dense, bright cluster of giant stars in one of the great star-forming clouds of that nearby galaxy, blazing so fiercely that it lights the gas for many light years around. To look upon it is to look upon the very upper limit of what a star can be, as massive and as luminous as nature seems able to make, a single point of light outshining whole swarms of ordinary suns. That dense cluster of giant stars is one of the most remarkable places in all the nearby universe, a tight knot of the heaviest, brightest stars known anywhere, gathered together in a single small region within a vast glowing nebula. Several of the most massive stars ever measured burn there together, many of them Wolf-Rayet stars or stars destined to become them, pouring out a combined torrent of light and wind that has carved a great glowing cavern in the surrounding gas. It is a furnace of creation, a place where the most extreme stars are forged in numbers, lighting up a nebula so large and so bright that it can be seen across the gulf between galaxies. The nebula that holds that bright cluster is so vast that, were it as near to us as the closest star-forming clouds in our own sky, it would stretch across a great span of the heavens and cast shadows on the ground at night. It is one of the largest and most active star-forming regions known anywhere in the nearby universe, a place where thousands of stars are being born at once, the most massive of them blazing into Wolf-Rayet stars and lighting the whole great cloud from within. From across the gulf between galaxies it glows as a single soft patch of light, but its true scale is beyond easy holding, a nursery of stars wide enough to swallow whole constellations. These stars are, for all their beauty, living near the very end of their lives. A Wolf-Rayet star is what the most massive stars become in their final chapter, after they have burned through nearly all their fuel, the closing phase before the great change that ends them. The fierce wind, the bared interior, the glowing veil, all of it is the sign of a star in its last brief age, having spent the long middle of its life and now blazing through the final pages. It is a kind of brilliant old age, this stage, not a fading and a dimming, but a last fierce flaring, the star burning all the brighter and shedding all the faster as it nears the close of its long story. What waits at the end of that story is one of the grandest events the cosmos holds, the explosion called a supernova, in which a massive star, having spent the last of its fuel, can no longer hold itself up against its own enormous weight and collapses inward, then rebounds outward in a single titanic burst of light. For a few weeks, that one dying star can shine as brightly as a whole galaxy of ordinary suns. Many Wolf-Rayet stars are thought to be stars in the very last age before such an ending, the bright, brief chapter that comes just before the great change. From your safe and impossible distance, it is only a far-off wonder, a thing to marvel at across an unbridgeable gulf, never a thing to fear. And because a Wolf-Rayet star has already shed its outer blanket of hydrogen, the kind of supernova it makes carries a particular signature of its own. When such a stripped star finally explodes, its light shows little or no sign of hydrogen at all, because the star had already flung that hydrogen away, long before the end, on its fierce wind. Astronomers sought the great stellar explosions partly by this very sign, and the ones that come from these bared hydrogen-stripped stars form a class all their own. So the long work of the wind, peeling away the star's outer layers across the ages, leaves its mark even in the final flash, a death whose very light remembers how the star had already given so much of itself away. In their last moments, a rare few of these stars may do something even more extraordinary. They may, as they collapse, send out a narrow beam of the most energetic light in all the universe, a brief and brilliant flash that astronomers call a burst of gamma rays. It is thought that some of the very fastest spinning, most massive stripped stars, in the instant of their collapse, can channel their titanic energy into two slender jets, firing out a beam that, for a few seconds, can outshine everything else in the sky combined. These bursts come from unimaginably far away, across billions of light years and billions of years, and reach us only as the faintest of flickers, a whisper of the most powerful light there is, arriving gentle and harmless after the longest journey imaginable. Hold the strangeness of that gently, from your safe place beneath it all, the most violent flash the universe can produce, born in the death throes of a great spinning star, travels for billions of years across the dark, so far that the star that made it died before the Earth itself was formed, before the sun was lit, before there was any here at all. And when at last that ancient flash arrives, it is so spread and softened by its endless journey that it brushes against the watching instruments for only a few seconds, harms nothing, troubles no sleep, and passes on. A titan's last cry, billions of years old, arriving as the faintest touch of light, and then gone, leaving the warm dark exactly as it was. When astronomers spread the light of one of these stars into its colours, they find not one bright band but many, a whole forest of glowing lines, each one the signature of a different element streaming outward in the wind. Helium glows here, carbon there, nitrogen or oxygen in their own places, each element marking its presence with its own bright stripe. To read that forest of lines is to take a complete inventory of the star's bared interior, naming every element shining in its wind and measuring how much of each there is. A single beam of light, fanned into its colours, becomes a full accounting of what a dying giant is made of, written in stripes of light no hand could ever have arranged. A star that ends in such an explosion may not die alone, for some of these giants have a companion circling them, a second star that can survive the blast. When the Wolf-Rayet star explodes, the shock sweeps past its companion, and that companion, jolted but enduring, may be flung off across the galaxy to wander alone ever after. Astronomers sometimes find such survivors, lone stars racing through space, carrying in their motion the memory of a partner that exploded long ago. There is a quiet poignancy in that, a star left travelling on alone, set loose by the death of the giant it once circled, bearing the mark of that lost companion across the rest of its long life. The sheer size of these stars before they shed themselves down is hard to hold in the mind. Some begin their lives so vast that our entire sun would seem a small bright bead beside them, many of them swelling wide enough that, were one set in the sun's place, its surface might reach far out toward the inner planets, and yet, as the fierce wind strips them down, they grow more compact, shedding their bloated outer layers until what remains is a smaller, denser, hotter core. So a Wolf-Rayet star is in some ways the shrunken, concentrated heart of a once enormous giant, the great soft outer body blown away, only the fierce bright centre remaining, burning all the hotter for being laid bare. The span of time these stars have been at their quiet work is hard to fathom. The galaxy has been making and unmaking giant stars for billions of years, since long before the sun was born, generation after generation of them blazing, shedding and dying, each one enriching the dark a little more. The Wolf-Rayet stars shining tonight are only the latest in that immense procession, the newest bright links in a chain reaching back almost to the beginning of the galaxy itself. To rest beneath one is to rest beneath a process older than the Earth, older than the sun, a slow and patient making that has been turning since the earliest starlight and will turn for ages still to come. But the end of such a star is not truly an ending at all, and this is perhaps the most consoling thing about them. When a Wolf-Rayet star explodes, it does not simply vanish. It scatters all the rich material it has forged, the carbon, the oxygen, the nitrogen, and heavier elements still, cooked up in its core and in the fury of its final blast, out into the surrounding dark, seeding the galaxy with the very stuff of new worlds. The atoms that were locked inside that one dying star are flung wide to drift among the clouds of space, to gather one day into new stars, new planets, perhaps even one day into living things. Nothing is wasted. The star gives itself away entirely, and from that giving, new things are made. You are made of such gifts. The carbon in every cell of your body, the oxygen in every breath you draw, the nitrogen and the iron and the calcium woven through you. All of it was cooked in the cores of giant stars and flung into space by their winds and their deaths, ages before this planet existed. Some of those very atoms may once have streamed away on the wind of a Wolf-Rayet star, or been thrown wide in its final blast, wandering the dark for an age before settling into the cloud that became the sun, the earth, and in time, you. The fierce thing you're watching tonight is the very kind of forge that made the atoms now resting warm and heavy in the bed beneath you. There is a long, slow cycle written into all of this, turning over ages beyond counting. A great cloud of gas gathers in the dark and condenses into stars. The most massive of those stars live brief, fierce lives, become Wolf-Rayet stars, and scatter their forged elements back into the dark when they die. That enriched gas gathers again into new clouds, which condense into new stars, each generation carrying a little more of the heavier elements than the one before. Around and around it goes, cloud to star to scattering to cloud again, each turning of the wheel building the universe up a little, seeding it with the heavier stuff from which planets and oceans and living bodies can one day be made. You are a late and lovely product of that patient turning. The heaviest elements take the most extraordinary forging, and these stars play their part in that too. The carbon and oxygen that fill the world were cooked inside such stars across the long fire of their lives. Heavier elements still, the silicon in sand and glass, the iron at the heart of every drop of blood, are forged in their final age and their explosive deaths. Even some of the rarest, heaviest metals trace their origins to the deaths of massive stars and the still stranger events that follow. So the gold in a ring, the iron in a nail, the very minerals beneath your feet, all of it was made somewhere, sometime in the fierce furnace of a great star's life and death, and scattered patiently across the dark to find its way, at last, to here. Consider how the very air you are breathing connects you to such stars. The oxygen filling your lungs at this moment, the thing that keeps the small warm fire of your life quietly burning, was forged in the hearts of massive stars and scattered into space when they died. Every breath you draw tonight is in a sense a breath of ancient starlight made solid. Atoms that once blazed inside a sun, flung out into the dark, gathered into a world, and drawn now softly in and out of you as you rest. There is a deep and quiet kinship in that thought, a thread connecting the slow rise and fall of your chest to the fierce, far-off stars that made the very air. Let your attention drift back out, across that unbridgeable gulf, to the star itself. For all its fury, the 100,000-degree heat, the wind tearing off its surface, the explosion that waits at the end, it is, from where you lie, utterly silent and utterly safe. No sound crosses the emptiness of space. The fiercest stellar gale makes no whisper that could ever reach you. The star burns and sheds and roars, and yet to you it is only a still bright point in a soundless dark, pouring out its light in perfect silence across a distance so vast that all its violence arrives, if it arrives at all, as nothing more than a gentle glow. Power and silence, fury and peace, held together in a single far-off light. The space between you and that star is almost entirely empty, and emptiness, it turns out, is a great keeper of peace. Between here and a Wolf-Rayet star lie thousands upon thousands of light years of nearly perfect vacuum, a dark so vast and so empty that the fierce wind of the star, pouring out faster than any rocket, takes ages upon ages merely to cross it, thinning and slowing and spreading until it is gentler than the faintest breeze. The very enormity of space is what makes these fierce things safe to rest beneath. Distance dilutes all fury. the great emptiness softens every violent thing until even the breath of a dying giant arrives as nothing more than a far and harmless shine. How astronomers learned all of this is itself a quiet wonder, for they have never touched a Wolf-Rayet star, nor ever could. Everything known about these stars has been read from their light alone, gathered patiently in great telescopes, spread into its colours and studied line by line. From the bright bands in that light, astronomers can tell which elements the star is made of. From the exact shape of those bands, how fast the wind is blowing. From the colours, how hot the surface burns. A whole portrait of a star halfway across the galaxy, painted entirely from the faint light that fell, after its long journey, into a waiting instrument. It is a kind of reading at an impossible distance, the cosmos confiding its secrets in nothing but light. The shape of those bright bands tells the most surprising story of all, for in their very form is written the speed of the wind. When a star's gas is racing outward toward you, its light is shifted a little toward the blue. When it streams away on the far side, a little toward the red. Because a Wolf-Rayet star's wind pours out in every direction at once, some of it always rushing toward you and some away, its bright bands are smeared out broad and wide across the colours, spread by the great range of speeds. From the exact width of that smear, astronomers can read directly how fast the wind is blowing. 1,000 kilometers a second, 2,000, measured not by any probe sent out to it, but by the simple stretching of its light. The very brightness of these stars makes them visible across enormous distances, like lighthouses set in the dark. Because a single Wolf-Rayet star can shine with the light of 1,000,000 suns, astronomers can pick them out not only in our own galaxy, but in others far away. Bright beacons standing out even among the crowded billions of stars in a distant galaxy's glow. In this way, these rare stars become useful markers, points bright enough to study across the vast gulfs between galaxies, helping astronomers trace where the most massive stars are being born across the wider universe. A thing so fleeting and so rare becomes, by sheer brilliance, one of the few individual stars we can pick out across millions of light years. Some of these stars wander the galaxy alone, far from the clusters where they were born, cast out long ago by some gravitational tumult among their stellar siblings. A massive star flung loose from its birth cluster goes coasting across the dark on its own, and as its fierce wind ploughs into the thin gas of space ahead of it, that gas piles up into a great curving arc before it, a bow shock, the very shape a boat's prow draws in still water. These wandering stars trail their glowing arcs across the dark like ships crossing a quiet sea, each one a lone giant travelling its own slow path, pushing a soft luminous wave of gas ahead of it through the night. The bow shock a wandering star draws can glow for light years, a faint curving wall of gas lit by the fierce light of the star that drives it. As the star coasts steadily through space, season upon season, age upon age, its wind forever sweeps up the gas ahead into that gentle arc, so that the star seems to wear a soft luminous crescent always before it, like the curl of foam at the prow of a slow ship. To find such an arc is to know a giant is travelling there, crossing the dark alone, and to trace the direction the arc points is to read the very path the wanderer is taking, written softly in glowing gas across the night. The most massive stars of all, the ones that go on to become these fierce shedding giants, are born wrapped in vast clouds of gas and dust, deep in the great star nurseries of the galaxy. They gather their enormous mass from those clouds across long ages, condensing out of the dark and then blaze into life so fiercely that their light and wind begin almost at once to blow away the very cloud that birthed them. A massive star is forever shaping its own surroundings, first gathering the gas to itself, then driving it away again with its fierce breath, carving out a hollow in the cloud until at last it shines clear, in a space it has swept clean with nothing but light and wind. Picture one of those star nurseries drifting towards sleep, a vast dark cloud, light years deep, scattered through with the faint glow of new stars kindling within it. In the densest knots of such a cloud, the most massive stars take shape, and as they ignite, they bore great glowing cavities into the surrounding dark, lighting the gas around them in soft pinks and golds. Among the brightest of those new stars are the ones destined, ages hence, to become Wolf-Rayet stars, though for now they are only newborn giants, blazing in the gas that made them. The whole cloud becomes a kind of slow garden of light, stars opening like blossoms in the dark, each carving out its own bright space. The fierce winds of these stars do more than sculpt pretty shapes. Across long ages they help to stir and shape whole galaxies. The combined breath of many massive stars blowing outward over millions of years pushes against the gas of a galaxy, sweeping it into great shells and bubbles, sometimes triggering the birth of yet more stars where the swept-up gas pile's densest. So these rare giants are not merely passive ornaments in the sky. They are part of how a galaxy churns and renews itself, their winds helping to stir the great slow currents of gas from which all new stars are born. A single star's breath is faint. The breath of many, across ages, helps move the very structure of a galaxy. There is a particular Wolf-Rayet star burning brilliantly in the southern sky, one of the most luminous and most massive stars in our entire galaxy, blazing with a light so fierce it would be among the very brightest objects in the heavens were it not veiled behind clouds of intervening dust. It pours out its enormous radiance from within a great glowing nebula, lighting the gas around it for many light years. Stars like this sit at the very upper limit of how massive and how bright a star can be, pushing against the ceiling of what the laws of nature will allow a single star to become. To look upon one is to see a star living at the very edge of possibility, as luminous as a star can be without tearing itself apart. Indeed, there is a kind of ceiling to how bright a star can shine, and these stars press against it. When a star grows luminous enough, the sheer pressure of its own light begins to push against its outer layers from within, threatening to lift them off into space. The most massive stars live always near this limit, their fierce radiance forever straining against the bonds of their own gravity, and it is partly this, the relentless outward push of their own light, that drives the great winds streaming off a Wolf-Rayet star. The star is so bright that its own light helps to blow it away, the radiance and the wind bound together, each feeding the other in a fierce bright balance. The hottest of these stars reach temperatures that beggar the imagination, far past the surface heat of nearly any other star that shines. A rare few Wolf-Rayet stars, the most extreme of all, blaze at surface temperatures approaching 200,000 degrees, many tens of times hotter than our own sun's face. At such heat, almost the entirety of their light pours out in the high, unseen energies beyond the visible, and what little reaches the eye is only the faintest hint of an inferno otherwise invisible. These are among the hottest stars known anywhere, not the largest, not the brightest by every measure, but the very hottest surfaced, blazing at the upper edge of what stellar fire can reach. Consider, drifting here, how strange it is that something so unimaginably hot can be a source of such calm to think about. The heat of these stars is beyond all human reach, beyond every fire and furnace, beyond anything you could ever stand near and live. And yet, across the vast cold dark, that same fierce heat reaches you as only a still point of blue-white light, no warmer to your watching eye than a distant star on a winter's night. The great gulf of space, the very thing that keeps you safe, is also what turns the inferno into a jewel. There is a deep restfulness in that the fiercest thing imaginable set far enough away becomes simply something lovely to rest your gaze upon in the dark. The wind of one of these stars, were you somehow able to watch it directly, would be a thing of ceaseless streaming motion, and yet, from a distance, it would seem perfectly still. Up close, the gas tears off the star's surface and races outward, faster than any rocket, faster than any meteor, a constant furious outpouring. But step far enough back, out to where you are floating now, and all that motion blurs into stillness. The star seems only to hang there, shining, while its fierce wind streams too far and too fast and too silently to register as movement at all. It is a violent thing wearing the face of perfect peace, the way a waterfall seen from very far away seems to hang motionless against a cliff. Some of these stars vary their light, brightening and dimming in slow rhythms over hours and days. The change comes not from the star itself, which burns on as steadily as ever, but from the thick wind streaming past in front of it, denser here, thinner there, so that a little more or a little less of the deep light shines through from one night to the next. The shift is slight, a small flickering at the very edge of measurement, far too faint for any eye to catch. Yet astronomers track it with careful instruments, watching the gentle rise and fall, and from that pulse alone they can tell how the unseen gas is moving and gathering far away. The wind is not perfectly smooth then, but full of structure, clumps, streams and swirls, like weather in an atmosphere blown outward into space. Within the great outflowing gale there form denser knots and thinner gaps, drifting and shifting as the wind races away from the star. It is as though the star carries its own ever-changing sky around it, a turbulent atmosphere flung outward faster than any storm, full of clumps that gather and disperse, and all of it unfolds in perfect silence around a star so distant that it is, for us, only a single point of light, a whole sky of weather wrapped about a star we will never touch, and never need to. There is a deep stillness at the centre of all this motion, the true surface of the star hidden forever beneath its glowing veil. No eye will ever see it. The dense wind wraps it round entirely, so that even the most powerful telescope sees only the outflowing gas, not the surface from which it streams. The real face of the star, the boundary where its substance begins, lies buried beneath layer upon layer of luminous wind, a hidden heart at the core of all that brightness. There is a quiet tenderness in that even a thing so brilliant and so studied keeps a hidden centre, a true self veiled forever behind the light it pours out. These stars spin, as all stars do, and some of them spin remarkably fast. A massive star is born turning, and as it lives and sheds its layers, that spin can speed up or slow down in complex ways. The fastest spinning of them may rotate so quickly that they bulge at their middles and flatten at their poles, their fierce winds blowing differently from equator to pole. And it is partly this rapid spin, in the most extreme cases, that may help channel the energy of a dying star into those narrow beams of gamma rays at the very end. A star's turning, begun in the cloud that birthed it, can echo all the way to the manner of its death. The wind a star sheds before it dies can shape the very explosion that ends it. By the time a Wolf-Rayet star explodes, it has already blown a great cavity in the gas around it, sweeping the space clean and piling the gas into a distant shell. When the supernova's blast races outward, it travels first through that swept clean hollow, then slams at last into the piled up shell, lighting it from within. So the shape of the dying star's final glory is written, in part by the wind it breathed across the ages before, the explosion blooming into a space the star itself had long ago prepared. Even in death, the star meets the surroundings of its own making. A Wolf-Rayet star lets you do something almost impossible with any other star, see it, in a sense, from the inside out. Most stars hide their forged interiors beneath an unbroken outer blanket, showing only their cool surface. Their deep workings stay forever sealed away. But a Wolf-Rayet star has blown that blanket off and shines through its bared interior, so that the deep forged elements glow openly in its light. To study one is to read the inner chemistry of a star directly, the long fusion of its life laid open to view. It is as though a single page of the star's hidden diary has been turned outward, the deep work of its core made plain for any patient reader. Far out in the streaming wind, where the gas crashes and shocks, these stars can fling a few particles to enormous speeds, accelerating them to nearly the speed of light. The colliding winds and violent shocks around a Wolf-Rayet star act like a great natural engine, hurling stray particles faster and faster until they go racing off across the galaxy as cosmic rays, fleet messengers that may travel for ages before brushing now and then against a distant world. So these stars seed the galaxy not only with elements and dust, but with swift particles too, quiet contributors to the unseen rain of cosmic rays that drifts forever through the dark. The clumps and streams within a star's wind can be watched, over hours and days, drifting across its face. As the dense, outflowing gas swirls and shifts, the bright bands in the star's light tremble and ripple, each small quiver marking a knot of gas moving outward through the wind. By following those ripples as they slide across the light, astronomers can trace how the densest clumps rise, sweep past and fade, reading the motion of a whole wind from nothing but the faint shimmer of its glow. It is a kind of distant weather watching, the slow storms of a far-off giant followed night after night from across the dark. The light from these stars carries another hidden message, written in the faint twisting of its rays. As starlight passes outward through the magnetized streaming gas of the wind, it can be subtly turned and aligned, so that careful instruments reading the light can learn about the wind it passed through and the field threaded within it. It is a kind of fingerprint pressed into the light itself, not in its colour or its brightness, but in the hidden grain of how it is oriented. From that faint signature, astronomers can read still more about a star they can never approach, recovering the shape of a wind across an unbridgeable gulf from nothing but the quiet alignment of its light. To gather all this faint information, astronomers point not only ordinary telescopes at these stars, but instruments that can see the unseen. Telescopes built to catch ultraviolet and X-ray light, lifted high above the Earth's atmosphere, where the air no longer blocks those high energies. Far above the weather and the clouds, in the cold and silence just outside the air, these high instruments swing gently toward the rare bright points of Wolf-Rayet stars and gather in the light that the eye can never see. Down below, on a dark and ordinary night, you rest, and far above, in the silent cold, the patient detectors drink in the invisible glow of dying giants, hour upon hour. It was the spreading of starlight into its colours, the simple act of passing light through a prism, that first revealed these stars and reveals them still. When Wolf and Rayet spread the light of those three faint stars in Cygnus, it was the unexpected pattern in the colours that told them they had found something new. And to this day, it is by spreading starlight into its rainbow and reading the bright bands within it that astronomers identify a Wolf-Rayet star, measure its wind, and name its kind. A whole science rests on the quiet fact that light, spread out, becomes a story. That a beam of light, gently fanned into its colours, will tell you what made it, how hot it burned, and how fast its wind is streaming. A whole human life is a single blink against the span of one of these stars. The brief final phase you're watching may last a few 100,000 years, and yet across all of recorded human history, a span of only a few thousand years, such a star would scarcely seem to change at all. Generations of watchers could be born and grow old, and the star would shine on almost exactly as before, shedding its substance grain by grain across spans of time no single life could ever follow. There is a strange comfort in standing before something so far beyond the pace of any human worry, a fire so slow that all our hurry simply falls away beside it. The reach of one of these stars extends far past the star itself, out across many light years of space. Its fierce light streams outward, lighting the gas for great distances. Its wind ploughs into the surrounding dark, carving and shaping it across vast reaches. Its shed elements drift outward to seed the gas for ages to come. A single Wolf-Rayet star touches a region of space so wide that whole crowds of ordinary stars could fit within its influence, sculpting and lighting and enriching everything around it. The star is one bright point, but its reach is enormous, a small, fierce heart at the centre of a vast sphere of its own making. To know one of these stars fully, astronomers gather its light across many kinds at once. The visible glow the eye can see, the ultraviolet beyond the violet, the X-rays from its colliding winds, the warm infrared of its dust. Each kind of light tells a different part of the story. The surface and the wind, the heat and the dust, the elements and the shocks. Only by gathering them all and laying them side by side does the full portrait emerge, a single star seen in many lights at once. It is patient, painstaking work, assembling, from scattered beams of every colour and energy, the whole living likeness of a giant no one will ever approach. There is a poetry in the idea that these stars wear their hearts on the outside. Most stars keep their forged elements hidden deep within, locked beneath layers of hydrogen that never see the light. But a Wolf-Rayet star has blown those outer layers away, bearing the deep forged material to open view, so that the elements cooked in its core glow openly at its surface for any instrument to read. It is the most candid of stars, hiding nothing of what it has made, turning its inner work outward into the light. You're looking, in a sense, at a star's open diary, the record of its long fusion written plainly across its glowing face. These stars are few in number, yet mighty in their effect upon the galaxy. Though only a few hundred shine in all the Milky Way, each one pours out more light, sheds more matter, and shapes more of the space around it than thousands of ordinary stars together. Their rarity belies their importance. They are among the great movers of the galaxy's gas, the chief forgers of its heavy elements, the sculptors of some of its loveliest shapes. A handful of stars, vanishingly rare against the billions, and yet their fierce brief lives leave a mark on the whole galaxy, out of all proportion to their number. The smallest crowd, doing some of the greatest work. The instrument that first revealed these stars opened far more than a single discovery. The spectroscope, that simple device for fanning light into its colours, became, in the years that followed, one of the great keys to the whole universe, the very tool by which astronomers learned what the distant stars are made of. Before it, no one knew the stuff of the heavens. After it, the light of every star became a message that could be read. The strange, bright bands of the Wolf-Rayet stars were among the early wonders that Tool revealed, a first hint of how much the colours of starlight could tell. From that humble fanning of the light grew a whole way of knowing the cosmos, still unfolding to this day. Many of the great glowing nebulae that fill the famous photographs of the sky owe their shapes in part to stars like these. Where a Wolf-Rayet star burns within a cloud, its fierce light and wind hollow out the gas, light it from within, and sculpt it into arcs and shells and curling filaments. The very forms that make such nebulae so lovely to behold. The grand portraits of glowing clouds that hang on so many walls hold, here and there, the bright fierce point of a Wolf-Rayet star at work shaping the beauty around it. To look closely at such an image is to find, amid the soft colour, the small bright sculptor that helped carve it all. The amount of material these stars fling away across their brief lives is staggering to hold in the mind. Over the few 100,000 years of its Wolf-Rayet phase, such a star can shed a mass equal to several of our own suns, pouring it out into the dark on its ceaseless wind. Picture that quietly, enough material to make several stars like ours, lifted off a single dying giant and scattered into space, grain by grain, year by year, until the star has given away a great part of all it ever was. It is the most generous dying imaginable, a slow, vast emptying of the self into the night, leaving the galaxy a little richer for the loss. That lost material does not vanish. It joins the great reservoir of gas that drifts between the stars, the thin and ancient medium from which all new stars are eventually born. So that great outpouring is, in a sense, a gift to the future, the star's substance scattered into the dark, mingling with the gas of space, waiting across long ages to gather again into new stars and new worlds. The star empties itself, and in the emptying sows the seeds of things not yet made. Nothing is truly lost. It only changes its form and waits, patient and scattered, for its next turning in the long, slow wheel of the cosmos. The clouds these stars enrich are themselves things of great beauty, drifting through the galaxy in shapes of soft colour and form. The gas between the stars is not empty, but full of vast tenuous clouds, some dark and cold, some glowing softly where starlight stirs them, and into these clouds the Wolf-Rayet stars pour the elements they have forged. Over ages those enriched clouds may collapse to form new stars, carrying within them more of the heavy elements than the stars that came before, so the galaxy slowly grows in richness, generation by generation of stars, each one seeding the gas a little more, the clouds drifting ever more fertile through the patient dark. Consider how brief a span the Wolf-Rayet phase truly is against the long life of a star. A star like our Sun will shine steadily for 10,000 million years. Even a massive star lives for several million. But the Wolf-Rayet stage at the very end may last only a few 100,000 years, a fraction of the whole, a final bright flourish occupying the last short page of a long story. If you imagine the star's whole life as a single long day, the Wolf-Rayet phase would be only the last few minutes before nightfall, a brilliant closing flare, brief and bright, at the very end of a long and luminous afternoon. Because the phase is so short, catching a star in the act of it is a piece of quiet good fortune. At any given moment, only a few hundred stars in all the galaxy happen to be passing through this stage. The rest are either too young to have reached it, or have already moved beyond it into their final ending. To find and study one is to glimpse a fleeting moment in a star's life, held almost motionless by the vast slowness of cosmic time, a single brief chapter caught still long enough to read. The galaxy is forever making and unmaking these stars. We are lucky to catch the few that happen to be shining in this stage just now. The names these stars carry are mostly plain and humble. Catalogue numbers, a letter, and some digits, set down by astronomers cataloguing the sky. There is a quiet charm in that plainness, that things so vast and so fierce should go by such modest names, a string of figures in a long list of stars. Behind each plain number lies a roaring giant far across the dark, shedding its substance into the night, and yet on the page it is only an entry, calm and orderly, tucked among its many fellows. There is a kind of peace in that orderliness too, the great wild cosmos quietly catalogued, each fierce star given its small tidy place in the human record. Some of these stars sit at the very heart of the loveliest nebulae in the sky, the makers of their own surrounding beauty. The fierce wind and radiance of a Wolf-Rayet star carves and lights the gas around it, so that the star and its nebula are bound together, the bright shell or spiral or bubble being nothing but the star's own breath made visible. To photograph one of these nebulae is to capture both the artist and the art in a single frame, the small fierce point of the star and the great soft cloud it has sculpted and lit, hanging together in the dark, the maker glowing at the centre of the made. The crescent nebula, that great shell in the swan, is still growing even now, its glowing edge pushed slowly outward by the fierce wind of the star at its heart. Across thousands of years the shell expands, sweeping up more of the surrounding gas, its delicate filaments brightening where the wind presses hardest. It is a slow sculpture, never finished, forever being reshaped by the breath of the star within, a thing not made once and left, but made continually, hour by hour, age by age, as long as the star keeps breathing out its wind. To see it is to see a sculpture caught in the very act of being made, its slow growth stretched across spans of time too long for any single life to follow. Far beyond our own galaxy, in galaxies millions of light years away, the same kinds of stars are blazing and shedding and dying, the same fierce, bright phase playing out again and again across the universe. Wherever the most massive stars are born, and they are born in every galaxy that makes new stars. Some of them, in their final age, become Wolf-Rayet stars, blowing their own bright bubbles, scattering their own forged elements into their own galaxy's dark. The phenomenon is universal. It is part of how the heavy elements spread through the whole cosmos, galaxy by galaxy, in the depths and winds of giant stars everywhere. The same story you're resting beneath tonight is being told at this moment in 1 billion galaxies across the sky. In the early universe, long ago, the very first massive stars may have passed through phases like this one, seeding the young cosmos with its first heavy elements. The earliest stars were made of almost nothing but hydrogen and helium, the simple gas left over from the beginning. The heavier elements did not yet exist, for no star had yet forged them. It was the lives and deaths of the first massive stars that began to fill the universe with carbon and oxygen and iron, the first sowing of the heavy elements, without which no planet, no ocean, no living thing could ever be. These fierce-shedding giants, or their ancient cousins, helped begin the long enrichment that made worlds like ours possible. The fierce light of the most massive stars helped, in the deep past, to clear the early universe of its primordial fog. For a long age after the beginning, the cosmos was filled with a thin haze of gas that light could not easily pass through. Then the first great stars kindled, and their intense radiance gradually burned that haze away, letting starlight at last travel freely across the dark. The most massive stars, the kind that end as Wolf-Rayet stars, poured out the fierce ultraviolet light that helped lift that ancient fog. In a sense, these giants helped make the universe transparent, opening the long, clear vistas across which all later starlight, and all later seeing, would travel. Think of that dawn, drifting now towards sleep, a young universe wrapped in a soft, thick haze, and then, here and there, the first fierce stars kindling within it, their light slowly clearing the fog around them in widening bright bubbles. Bubble met bubble and merged, until at last the haze was gone and the cosmos lay open and clear, ready for all the starlight of every later age to cross. The most massive stars, blazing fiercest of all, did much of that gentle clearing. There is something restful in the thought that the very clarity of the night sky was won long ago by the fierce bright lives of giant stars. Across the long history of the cosmos, generation after generation of massive stars has enriched the gas of the galaxies, each adding its forged elements to the slowly thickening brew. The first stars sowed the first heavy elements, their descendants sowed more, and so, across billions of years, the gas of the universe grew steadily richer, until at last it held enough of the heavier stuff to make rocky worlds and oceans and living things. The Wolf-Rayet stars of every age have been part of that long, patient enriching, one bright link after another in a chain stretching back almost to the beginning, building the cosmos slowly toward the possibility of worlds like ours. There is something restful in knowing that you are a late chapter in so long a story. The atoms in your body were forged across billions of years, in generation after generation of stars scattered and scattered again, long before the Earth took shape. The carbon, the oxygen, the iron resting in you tonight passed through the hearts, and the winds and the deaths of stars uncounted, drifting through the dark for ages before they ever gathered into a world, into a body, into you. You're not separate from these far-off fires. You're made of their leavings, a small warm gathering of ancient starlight, resting now in the dark beneath the stars that are still making more. The colours a Wolf-Rayet star paints across its surrounding gas are among the softest and most varied in all the heavens. Where its fierce ultraviolet light strikes the surrounding clouds, it makes them glow. Hydrogen in deep rose red, oxygen in green and teal, other elements in their own faint hues, all of it blending into the delicate watercolour washes that fill the great nebulae. These are not garish colours, but soft and luminous ones, glowing gently across light years, the gas lit from within by the unseen light of the star. To rest your gaze on such a nebula is to look upon a vast soft painting, made of nothing but glowing gas, and the patient light of a dying star. The shells these stars blow can grow to enormous size, light years across, vast enough to swallow whole star systems within their glowing bounds. The Crescent Nebula spans perhaps 25 light years. Other Wolf-Rayet bubbles are larger still. To stand within such a shell, though no one ever could, would be to find oneself inside a glowing sphere so vast that its far walls would be utterly out of reach. A luminous cavern light years wide, blown by the breath of a single star. From outside and far away, it is only a soft round glow in the dark, but its real size strains the imagination, a bubble of light wide enough to lose whole worlds inside. The pinwheel stars, with their slowly turning spirals of dust, are among the most graceful clocks in all the cosmos. One whole loop of the spiral grows with each circuit the two stars complete, so that the shape itself records the passing of time, turn after turn, coil after coil, a year for every loop. Astronomers can read the age and the rhythm of the system from the spacing of the coils, the way you might read the years of a tree from the rings within its trunk. It is time made visible, written in dust and starlight, a slow record of two stars circling endlessly in the dark, each coil a season completed and laid gently down. Think of how patient such a spiral is in its making. Coil by coil, over years and decades and centuries, the two circling stars lay down their dust, the great pinwheel widening with each turn, never hurrying, never pausing. The dust laid down 100 years ago has drifted far out now, faint and wide. The dust laid down last year is bright and close to the stars, and in between, ring upon ring, the whole patient history of the system unwinds outward into the dark. It is one of the slowest sculptures the cosmos makes, and one of the loveliest. A thing built grain by grain across the ages, asking nothing, finishing never. The wind speeds of these stars are among the very fastest steady flows known anywhere in nature. 1,000 kilometers a second, 2,000, sometimes more. This is not a sudden burst but a constant, sustained outpouring, held steady across the whole brief life of the star. There is little in all the universe that moves so fast so continuously. Even the fierce winds of other hot stars rarely match it. To picture the speed, imagine crossing the whole width of the Earth not in a day, not in an hour, but in a handful of seconds. And then imagine that speed never slowing, never resting, pouring outward without pause for hundreds of thousands of years. That is the breath of a Wolf-Rayet star. And yet, for all that ferocious speed, the wind makes no sound at all, for space is silent, and so the whole fierce outpouring unfolds in perfect quiet. There is no air to carry a sound, no medium to bear a roar. The gale that would deafen any ear simply streams outward in absolute silence. The star tears itself apart at a speed beyond any reckoning, and the night around it stays as still as ever, soundless and serene. From your safe distance you watch a violence beyond imagining unfold without the faintest whisper, a great silent breath, poured endlessly into a silent dark, asking nothing, waking no one. There is a particular peace in objects that are vast and far and utterly indifferent to us. The Wolf-Rayet star you are watching does not know you are there. It would shine and shed and die exactly the same whether or not any eye had ever turned toward it, whether or not the earth had ever formed, whether or not there were anyone at all to wonder at it. There is a profound and easeful freedom in that to be for one night nothing more than a quiet onlooker before something so grand and so wholly unconcerned with you, something that asks nothing, expects nothing, and would not notice if you slipped quietly away into sleep. Its grandeur is entirely its own, and it shares it freely with no thought of return. The light you would see from such a star tonight set out long ago, long before you were born, long before the room you are lying in was built. The nearest Wolf-Rayet star is well over 1,000 light years away. Most are many thousands. So the light arriving from one of them now began its journey across the dark while ancient empires still stood, or long before, travelling faithfully across the void all that time to reach at last a single watching eye. To look at one is to look into the deep past, to see the star not as it is now, but as it was when its light departed. A message from long ago, arriving softly in the present, asking only to be received. A few of the dust grains these stars make have, astonishingly, been found and held in human hands. When the cloud that became our solar system gathered together, it swept in tiny grains of stardust forged in the winds of giant stars long dead, and a few of those grains survived, locked inside ancient meteorites that have since fallen to Earth. Scientists have teased them out, motes of stardust older than the sun itself, some of them bearing the chemical signature of the carbon-rich winds of Wolf-Rayet stars. To hold such a grain is to hold a speck forged in the wind of a star that died before the Earth was born, a fragment of an ancient giant carried across the ages, resting at last in a laboratory drawer. Picture that drifting towards sleep, a single grain of soot, finer than dust, forged in the streaming wind of a dying star somewhere out in the dark billions of years ago. It drifted through space for an age, outlived the very star that made it, and was swept into the cloud that became the sun and the earth and everything upon it. It rode inside a stone for the whole long history of the planet, and then fell from the sky and was found. There is something deeply moving in that a fleck of a star's last breath could survive so long, and travel so far, and come at last to rest in a careful human hand. Some Wolf-Rayet stars have even been caught in the very act, their light fading from the sky as the star that shone there explodes. When a distant supernova flares, astronomers sometimes search old images of that exact spot in the sky, and find, in the years before, the faint point of the star that died, and now and then that vanished star bears the marks of a stripped-bared giant. To match a fading explosion to the star that made it is to close a long circle, confirming with the eye what the equations had long suggested, that these fierce shedding giants are indeed among the stars that end in the great blooms of light. The star is gone, but its final portrait remains, caught in the patient record of the watching sky. Some of these stars may, in the moment of their death, leave behind not a scattered nothing but a dense dark remnant, a collapsed core, a neutron star, or even a black hole born in the heart of the explosion. The outer parts of the star are flung wide as the supernova blooms, but the very centre may collapse inward to form one of the densest objects the universe holds, a small dense ember left turning in the dark where a giant once blazed. So the death of a Wolf-Rayet star can be both a scattering and a making, the outer self given away to the galaxy, and a strange dense seed left behind, the last small heart of a once enormous star. Consider that arc drifting towards sleep. A star is born huge and bright from a cloud of gas. It lives a brief fierce life. In its final age it sheds its outer self on a great wind and becomes a Wolf-Rayet star. Then it explodes, scattering its forged elements wide, and at the centre, perhaps, a small dense remnant is left, while the scattered gas drifts off to seed new stars. The whole vast life, from cloud to giant to wind to blast to remnant and back to cloud again, is a single long turning of matter through fire and dark. You are a small warm product of countless such turnings, resting now beneath a star caught in the midst of one. The matter flung out in such a death travels for ages before it gathers anywhere new. The scattered gas drifts through the dark at speeds that seem fast and yet, against the vastness of space, are achingly slow, taking thousands upon thousands of years merely to spread across the region where the star once burned, and far longer still before it gathers into any new cloud dense enough to make a star. Patience is written into the very fabric of the cosmos. Nothing here is hurried. The gas of a dead giant may drift for millions of years before it finds its next form in no rush at all, with all the time in the universe to find its way. There is a deep gentleness in how unhurried all of this is. The fierce wind that seems so violent up close takes ages to cross the empty dark. The explosion that ends the star unfolds by cosmic measure in a flash, and then the scattered gas drifts for ages more, patient and slow. The clouds gather across millions of years. The stars take shape across hundreds of thousands more. From far enough away, even the most violent events in the universe become slow, soft and stately, unfolding across spans of time so vast that they seem hardly to move at all. There is rest in that vastness of time, a sense that there is no hurry anywhere and never has been. The very rarest of these stars, the ones stripped down to where oxygen shines brightest in their light, are among the rarest individual stars known anywhere, only a small handful catalogued across the entire galaxy. To find even one is a singular event, noted and studied with care. These are stars stripped almost to the bone, bearing layers of their interior that almost no other star ever shows, glowing with the signature of the deepest material they hold. They are the most extreme of an already extreme kind, a few precious points of light scattered across the entire breadth of our galaxy, each one a small wonder pulled patiently from the dark. Astronomers find new ones only now and then, the catalogue growing slowly by ones and twos across the years. Each new Wolf-Rayet star discovered is a small, quiet event in the world of those who study the sky. A faint new point identified, its light spread and read, its kind determined, its name set down. The list lengthens not in floods but in trickles, mirroring in its own slow way the rarity of the stars themselves. It is a science of patience and attention, of long-looking rewarded now and then by a single faint new find, added gently to the roll of the known. The total number of these stars known in our galaxy is still only a few hundred, though astronomers believe there may be a few thousand more hidden behind the dust waiting to be found. The great spiral of the Milky Way is wide and thick with obscuring clouds, and many a Wolf-Rayet star surely burns behind those curtains of dust, its light dimmed and reddened, hidden from easy view. So the catalogue is incomplete, a partial census of a hidden population, and each new instrument that can peer through the dust reveals a few more. There is something restful in that thought too, that the galaxy holds more wonders than we have yet found, patient and undiscovered in the dark. To find those hidden ones, astronomers look in infrared light, the warm, low light beyond the red end of the rainbow, which slips through the obscuring dust far more easily than visible light can. In infrared, the dust grows transparent and stars hidden behind it shine through, revealing Wolf-Rayet stars that the eye could never have seen. So by gathering the warm unseen light beyond the red, astronomers have pulled many more of these stars out of the hidden depths of the galaxy, peering through the dusty curtains to find the fierce giants burning behind them. The unseen light reveals what the visible never could, a whole hidden population glowing softly in colours no eye can hold. There is a tenderness in the thought of all those hidden stars burning unseen behind the dust. Across the great spiral of the galaxy, in regions thick with obscuring cloud, Wolf-Rayet stars surely blaze that no eye has ever caught and no instrument has yet found. Fierce bright giants shedding their substance into the dark entirely unwitnessed, asking for no audience. They shine on regardless, indifferent to whether anyone sees them, pouring out their light and their wind into the patient dark. There is a quiet dignity in that, a brilliance spent freely in secret, a beauty that needs no witness to be real. The phase these stars are passing through marks them as the future makers of the heaviest elements, the forges from which the stuff of worlds will come. Through their last fierce age and the great blasts that end them, they cook and scatter the carbon and oxygen and heavier elements that drift out to seed new stars and planets. So these fierce dying giants are in a sense the great fertilizers of the cosmos, enriching the galaxy with the raw material of future worlds and future life. Every planet that will ever form, every ocean that will ever fill, every living thing that will ever breathe, owes some part of its substance to the deaths of stars like these. It is worth resting for a moment, on how much these stars give and how little they keep. A Wolf-Rayet star spends its final age flinging away the greater part of all it is, its outer layers stripped and scattered, its forged elements sown across the dark, its very mass diminished year by year until, at the end, it gives away nearly everything in a single great blast. It hoards nothing, it keeps nothing back. It pours itself out entirely into the night, leaving the galaxy richer and itself spent. There is a kind of grace in that, a generosity so complete it asks for nothing in return, a giving away that seeds the future even as it ends the self. Our own sun will never become one of these fierce-shedding giants, and there is a quiet comfort in that. A star must be born many times heavier than the sun to end its life this way. Our modest yellow star is far too small. When its long fuel finally runs low, billions of years from now, the sun will not tear itself apart on a furious wind or blaze for a final age in blue-white fury. It will swell gently into a soft red giant, shed its outer layers in a slow and lovely breath, and settle at last into a small white ember, cooling quietly in the dark. The grandest deaths are reserved for the grandest stars. Ours will be among the gentlest, a soft fading rather than a fierce one. The path a massive star takes toward this final phase can pass through other strange and beautiful stages first. Some of the very heaviest stars, before they become Wolf-Rayet stars, swell into vast unstable giants that brighten and dim in great slow surges, throwing off enormous shells and clouds in fitful bursts. Astronomers watch these restless giants shrug off shell after shell of their own substance, building great glowing structures around themselves until at last the layers are stripped away and the bared, fierce Wolf-Rayet phase begins. The road to this final flourishing winds through some of the most dramatic and lovely transformations a star can undergo, each one shedding a little more, bearing a little more of what lies within. Whether a star reaches this phase at all depends in part on the very stuff it was made from. Stars born from gas already rich in heavier elements tend to have stronger, thicker winds, and so they shed their outer layers more readily and reach the bared Wolf-Rayet stage more easily. Stars born from purer, simpler gas, poorer in heavy elements, hold their outer blankets more tightly and may reach this phase only with a companion's help. So the history of a whole galaxy, how enriched its gas has grown across the ages, shapes how readily it makes these fierce-shedding giants. The stars and the galaxy that holds them are bound together, each generation shaping the next. In galaxies richer in heavy elements than our own, these stars are more common. In poorer, simpler galaxies, they are rarer and form by different paths. Astronomers studying galaxies across the universe find the Wolf-Rayet stars distributed in ways that reveal the chemical history of each galaxy. More of them where the gas is rich, fewer where it is plain. So these rare giants become a kind of reading instrument for the cosmos, their numbers telling the story of how each galaxy has been enriched across billions of years of star birth and star death. A single fierce star by its mere presence helps tell the long quiet history of the galaxy that made it. There is a thought worth holding, drifting now towards sleep, that the universe is forever making and unmaking, gathering and scattering in a great slow rhythm without beginning or end that you can find. Clouds gather into stars, stars live and die and scatter their substance. The scattered gas gathers into new clouds, which make new stars. The Wolf-Rayet stars are one bright moment in that endless turning, the fierce final flourish of the greatest stars scattering the richest gifts, and you are another moment in it, a small warm gathering of star stuff, resting for one night beneath the great wheel as it turns, made of its leavings, soon to give your own atoms back to it, all in the fullness of unhurried time. How much of the universe's beauty unfolds in colours we will never see? The Wolf-Rayet stars pour out most of their light in the ultraviolet, far beyond the violet edge of the rainbow, in shades the eye was never made to hold. Their dust glows in the infrared, beyond the red edge, in warmth no eye can catch. Most of the radiance of these fierce stars passes by us entirely unseen, blazing in colours forever outside the small bright window of human sight. There is a quiet wonder in that the cosmos glows in hues we cannot perceive, all around us, all the time, and that we are none the poorer for it, the dark none the less beautiful for the colours hidden within it. The instruments that gather this unseen light are themselves quiet marvels, lifted high above the earth to drink in radiance the ground could never receive. Telescopes built to see ultraviolet and X-rays must rise above the atmosphere, for the air that lets us breathe also blocks those high energies, shielding the surface from them. So, high in the cold and silence beyond the air, these orbiting eyes turn slowly toward the rare, bright Wolf-Rayet stars and gather their invisible glow, hour upon hour, sending the faint data down to the watchers below. Far above your resting head, even now, such an instrument may be drinking in the unseen light of a dying giant on the far side of the galaxy. It is worth dwelling on the sheer distance such light has crossed to reach those instruments. The light gathered from a Wolf-Rayet star far across the galaxy set out into the dark when the world was young, when great glaciers still lay across the northern lands, when no city had yet been built, when no word had yet been written. All that time the light travelled, never resting, never slowing, crossing an emptiness so wide that the mind goes soft trying to hold it. And then, after that immense and patient journey, it arrived, falling at last into a waiting instrument, delivering its ancient message and passing on. A message from the deep past faithfully carried across the longest distance imaginable. There is a particular piece in numbers too large to truly grasp. A wind of 1,000 kilometers a second, a temperature of 100,000 degrees, a distance of tens of thousands of light years, a mass shed equal to whole suns. These numbers are so far beyond the scale of anything in daily life that the mind cannot hold them as it holds ordinary things, and so it simply lets them go and floats. There is rest in that, in numbers so vast they slip past worry entirely, so far beyond the reach of anything you have to do tomorrow that they carry the mind out past all its small concerns and set it gently adrift in the wide dark. These stars remind us that even the most violent things in the cosmos can be, from a distance, sources of deep calm. The fierce wind, the searing heat, the explosive death, all of it set far enough away becomes only a still bright point in a soft glowing shell, lovely and harmless and serene. The very distance that keeps you safe is what turns the violence into beauty, the inferno into a jewel, the dying giant into something restful to gaze upon in the dark. There is a deep reassurance in that the universe holds nothing that can trouble you here, in this warm and ordinary room, beneath the soft far light of stars that cannot reach you. The story of these stars is still being written, even now, in giants not yet collapsed. Somewhere out in the galaxy at this very moment, massive stars are living their brief bright lives, all unaware of what they will one day become. Ages hence they will shed their outer layers and blaze for a final brief age as Wolf-Rayet stars, and then explode, scattering their gifts into the dark. The universe is forever making new ones, and will go on making them long after this night, and everyone who shared it have gone to their own rest. There is a deep and restful humility in that, to be, for one night, a small warm witness to a story so much longer than ourselves, a story still being told in stars not yet born. Some of the gas these stars have shed is still glowing in the sky, lit by stars that themselves may already have died. Light takes so long to cross the dark that a Wolf-Rayet star many thousands of light years off might already have exploded, its great change unfolding even now, and yet to us its light still shows it blazing and shedding, for the news of its ending has not yet had time to arrive. So some of the stars you might gaze upon tonight may, in truth, already be gone, their final light still crossing the dark toward us, a kind of beautiful afterglow of a thing already changed. There is a strange tenderness in seeing, in the present, a light from something whose story has already moved on. Consider how much patience is woven into the watching of these stars. The astronomers who study them may watch a single pinwheel turn for years before they see its full rotation. They may wait decades to find a single new one. They may gather the faint light of a distant giant hour upon hour, night upon night, to build a single careful portrait. It is a science of long attention, of patience rewarded slowly, of watchers content to wait across years for the sky to yield its secrets a little at a time. There is a deep calm in that patience too, in a way of knowing that does not hurry, that is content to gather understanding slowly across the long unhurried turning of the years. The light of a Wolf-Rayet star, spread into its colours and studied closely, reveals not only what the star is made of and how fast its wind blows, but how the wind changes over time, how the star spins, how it varies, how it lives. From a single faint beam of light, astronomers can reconstruct an entire living portrait of a star they will never approach. Its composition, its motion, its weather, its history, all read from the patient analysis of light gathered across the dark. It is a thing to marvel at softly, that so much can be learned from so little, that a thread of light can carry the whole story of a star across the immense gulf of space and lay it gently open before a watcher on Earth. There is something deeply restful in the thought that the universe explains itself in light. Everything astronomers know of these stars, as their fire, their wind, their elements, their fate, was learned not by touching or by travelling, but by patiently reading the light they pour into the dark. The cosmos confides its deepest secrets in the gentlest of messengers, in beams of light that ask nothing of us but to be gathered and read. And those beams arrive freely, endlessly, falling out of the dark sky onto any instrument turned to receive them, bearing the stories of fierce far things in a language as soft as light itself. The universe is forever speaking, quietly, in light, to whoever cares to listen. Even the fiercest of these stars will one day grow quiet. After the brief Wolf-Rayet age, after the great explosion, what remains is either a scattered cloud of glowing gas, slowly drifting and cooling into the dark, or a small dense remnant turning silently where a giant once blazed. The fury passes, the violence ends. What was a roaring giant becomes in time only soft drifting gas and a quiet dense ember. There is a deep gentleness in that arc, the sense that even the most intense things the universe can make are allowed in time to set their fury down and grow still. Nothing fierce lasts forever. Everything, at the last, is permitted to rest. The scattered gas of a dead Wolf-Rayet star glowing softly as it drifts is one of the loveliest sights the sky can offer. A great soft cloud of luminous gas, threaded with delicate filaments, glowing in the gentle colours of its elements as it spreads slowly into the dark. These remnant clouds, lit by the fading energy of the explosion or by nearby stars, hang in the sky like vast soft veils, drifting and cooling across the ages. To gaze upon one is to see the gentle aftermath of a great event, the violence long past, only the soft glowing gas remaining, spreading patiently outward into the patient dark. Think of how the great explosion, for all its fury, leaves behind such softness. The blast that ends a Wolf-Rayet star is among the most violent events the cosmos holds, and yet what it leaves, across the ages that follow, is only a gentle drifting cloud and a small, quiet remnant, the fury rendered down at last into soft glowing gas spreading slowly through the dark. The violence is a single brief instant. The softness that follows lasts for ages. From far enough away and long enough after, even the death of a giant becomes only a soft luminous veil hanging quietly in the night, lovely and harmless and slow. There is a kind of immortality in the way these stars give themselves away. Though each Wolf-Rayet star ends, the elements it forged and scattered do not end. They drift on, gathering into new stars and worlds, becoming part of everything that comes after. So in a sense, the star does not truly die, but disperses, its substance carried forward into the future, into new suns, new planets, perhaps new life. The atoms it forged will outlast it by ages beyond counting, woven into the fabric of worlds not yet made. There is a deep consolation in that nothing of the star is truly lost, that its giving away is in truth a kind of going on. Consider, drifting now, that the very stuff of you will one day be given back to the cosmos in just the same way. The atoms that make you, forged in stars scattered across the dark, gathered into a world and into a body, will not stay forever where they are. In the fullness of time, in no hurry at all, they will be released again, to drift and gather and become part of whatever comes next, as the atoms of dead stars become part of new ones. You're a brief and lovely gathering of ancient star stuff, borrowed for a little while from the long turning of the cosmos, and there is a deep peace in that, in being a small warm part of something so vast and so unhurried. The Wolf-Rayet stars sit near the very top of the scale of stellar mass, among the heaviest stars that can ever form. There is a limit to how massive a star can be. Grow too heavy, and the sheer pressure of its own light would tear it apart before it could ever stabilize. The most massive stars live always near that limit, and a great many of them, at the very end, pass through this fierce shedding phase. So to look upon one is to look upon a star living near the very ceiling of possibility, as massive as a star can be, pressing against the outer bound of what physics itself permits. They are the giants among giants, the heaviest of the heavy, blazing at the edge of what can be. And yet, for all that staggering mass, a Wolf-Rayet star is forever shedding it, growing lighter year by year as its fierce wind carries its substance away. The heavier stars are also the most prodigal, giving away their great mass faster than any other kind of star. There is a strange beauty in that the most massive things in the cosmos are also the most generous, pouring out their vast substance into the dark at a furious rate, growing lighter even as they blaze, until at the end they fling away nearly all that remains in a single great gift. The greatest stars hoard the least, the heaviest give the most freely. These stars represent a kind of bridge between two great phases of stellar life, between the long bright burning of a massive star's middle age and the final explosive ending that awaits it. The Wolf-Rayet phase is the threshold between them, the brief bright doorway through which the greatest stars pass on their way from blazing to ending. To catch a star in this phase is to catch it on the very threshold, poised between its long life and its great death, blazing all the brighter as it crosses over. There is something quietly profound in that, a star caught in the act of passing from one great state to another, its crossing made visible to us only because the cosmos moves so slowly. The discovery of these stars long ago in Paris opened a whole new chapter in the human understanding of the heavens. Before Wolf and Rayet noticed those strange bright bands, no one had known that stars could shed themselves so fiercely, or bare their interiors so openly, or shine with the glowing light of their own outflowing wind. The finding widened the known world, revealing a kind of star no one had imagined, and beginning a long inquiry that continues to this day. There is a soft marvel in that one evening's careful looking at 3 faint points of light could open so vast a new room in the house of human knowledge, and the inquiry they began is far from finished. Even now, astronomers are still learning how these stars form, how their winds work, how exactly they end, and what part they play in the great cycles of the cosmos. Each new instrument, each new observation, reveals a little more, and the picture grows slowly richer across the years. There is a quiet ease in that ongoingness, in a question that is never fully closed, a mystery that yields its secrets slowly, and always holds little more in reserve. The Wolf-Rayet stars are not a solved thing but a living study, still unfolding, still surprising, still holding wonders not yet found. There is a deep peace in knowing that the cosmos is wider and stranger, and more generous with its marvels than we ever quite assume. The Wolf-Rayet stars, with their fierce winds and their glowing veils and their slow-turning spirals of dust, were unimagined before they were found. And surely there are wonders still unimagined, waiting out past the edge of what we now know, patient and undiscovered in the dark. The universe keeps its surprises gently, revealing them a little at a time to those who look. And there is comfort in that vast unknown, in the sense that there is always more beauty out there than we have yet seen, more wonder than we have yet found, waiting quietly in the deep. Let your attention rest one last time on the star itself, that single fierce point of blue-white light far across the galaxy, shedding its substance into the dark on a wind faster than thought, wrapped in a soft glowing shell of its own breath, burning at a heat beyond all imagining, and yet, from where you lie, only a still and lovely jewel set in the black. It does not know you are watching. It asks nothing of you. It would shine exactly the same if you slipped quietly into sleep this very moment. There is a deep and restful peace in being, for this one night, only a witness to something so vast and so far and so beautifully indifferent, held, along with all your cares, in the great soft dark that surrounds it. Far across the galaxy, in a dense knot of newly forming stars, there may be a young giant just now drawing its first fierce breath of wind, a star that will one day, ages hence, become a Wolf-Rayet star of its own, shed its layers, blaze for a final brief age, and scatter its gifts into the dark. The story is beginning again, even now, in clouds of gas light years away, in stars not yet old, in winds not yet risen. The universe never stops making these fierce, generous giants. It has been making them since the first stars lit, and it will go on making them long after the last of us has gone to rest. And that, perhaps, is the most consoling thought of all, that the great work of creation continues, patient and unhurried, with or without anyone to witness it, scattering the stuff of new worlds across the dark, age upon age, world without end. You have come a very long way tonight, out past the planets and the scattered stars, to the rarest and most generous giants in all the sky. There is nothing left to reach for now. The bright star will keep shedding its light without you. The dark will hold it and hold you, exactly as gently as it has all along. And if you're still here, drifting at the soft edge of sleep, another quiet journey is already waiting for you on the screen, ready to carry you onward through the dark whenever you wish, or never at all. There is nothing you need to choose. It will wait as long as you like. For now there is only this, the heaviness of your own resting body and the slow shining far away. You do not need to carry any of it with you into sleep. Not the numbers, not the names, not the fierce winds or the distant fires. Let all of it loosen now, the way the hands open in sleep without being told to. The facts have done their quiet work. You may set them down. What stays will stay on its own. What slips away was only ever passing through. Feel the weight of your body now settled and warm, far from the heat and the distance, here in this safe and ordinary dark. The star is shining, tens of thousands of years away, and you are resting here, where nothing fierce can reach you. Let your breath grow slower. Let your thoughts grow dim, one by one, like faint lights going quiet at the edge of a wide field at night. There is nothing more to know. There is nowhere else to be. There is only the soft dark and the warmth of where you lie, and the slow easing of everything you are holding. Let it go now. Let yourself grow heavy. Let the long night close gently over you, like a tide coming in. And now 101 wonders are resting with you. Sleep now. Good night.